So I'm Phoebe. I'm a PhD student here at UQ. Just started sort of a while ago. Our symposium session today is from small to large scale marine coastal restoration. So this is a theme, sorry if I'm a bit loud, this is a theme that has been recurring, and so we were really interested to just explore this a bit more, and I'm just going to give an intro to it. None of my work, I'm just going to cycle through some examples that I thought were cool, which I'm going to say now because mostly it's plugs for talks that we're going to have this week. So, where are we? Where's my face? There it is. So marine coastal restoration, this is a picture of me. I'm originally an ecologist. I didn't realise I was going to be having professional work photos that day, that's why I'm wearing that t-shirt. But, moving right along. Why marine coastal ecosystems needed? This is the research that I will be working on. I've been looking at climate change, impacts on coastal restoration, on coastal ecosystems, and how coastal restoration can actually mitigate and help us to adapt to climate change. So ecosystem services that coastal marine environments provide are things like food sources, so fisheries, blue carbon, so that's really important for environments like mangrove, salt marsh, seagrasses. We're sort of debating kelp forests, so if you kelpie guys can give me some incentive to add you to my research, I'll think about it. Storm protection, so corals, coral reefs and oyster reefs can really mitigate wave attenuation when we have extreme storm events, which we're likely to have more of as climate change progresses. Tourism and recreation, so these are values for our economy, so I'm going to talk about that a bit more in a bit. So these are really important ecosystems, as I've just said. They're all on the decline. Mangroves have declined 35% globally. These are estimates that I've sort of tried to put together from a bunch of different sources. But we all know that these ecosystems are under threat, and what are we going to do about that? So what I want to point out with the next couple of slides is that we're living in a post-climate change world. So I try not to talk about climate change as if it's going to impact us, because we've got lots of examples of the impacts that it has already had. So a few Australian examples. Great Barrier Reef, since I've got a bunch of Great Barrier Reef enthusiasts here. This is from the surveys in 2016-2017. As you can see, there's bleaching in the north, and then in the middle reaches the Great Barrier Reef. Huge bleaching events. We've lost a lot of the reef. And luckily for the Great Barrier Reef, there's been a lot of investment. You can see at the bottom there I've put down the Great Barrier Reef Foundation, and I haven't put any value there. They just got 444 million, but who knows if they'll keep that. So, a bit political. Also in Australia, same thermal event as the coral reef, Great Barrier Reef bleaching events, late 2015, early 2016. These extreme weather events for the mangroves were high temperatures, low precipitation and storm winds. And what happened is that it affected 1,000 kilometres of shoreline in the Gulf of Carpentaria, and lost about 6% of the mangrove vegetation in the affected area. Also, I want to talk about seagrass. There's a seagrass restoration symposium tomorrow in room 3 at 1 p.m. So come along, they're not just grass, Ian. So that'll be really cool. These guys had a marine heatwave 2010-2011. I think, John, are you going to talk about this at all? Hopefully. Yeah, so John will talk about that. Lost about 20% of seagrass, and there was a contraction in the range, and some areas of Shark Bay. This is all filched from the internet, hopefully it's cool. Yeah, 90% dieback in some regions of Antarctica, and this had flow-on effects for green turtles, since that's what they eat. Kelps, put that in there for kelp enthusiasts. They had a heat wave in 2011 in WA, and what this what happened with this is that there was a 100-kilometre range contraction, and those are the same sort of contractions that we've seen and have been documented in bird species, in tree species, and this is a really interesting case of climate change already impacting upon a marine ecosystem. So those kelp forests have been lost, and there hasn't been that much recovery as far as I could tell by having a quick squiz on the internet. But again, kelp, 3 p.m. tomorrow, and a session that I'm chairing again in room 3, so not this room, so that's tomorrow. So what do we need to do? We need to restore these environments. Because they're valuable. And what I'm interested in terms of the value of marine coastal ecosystems is their value in climate change adaptation and mitigation. So mitigation, things like carbon sequestration, blue carbon, reduction in the local sea level rise, and adaptations could be things like coastal protection, flood defence, and ecosystem resilience by building up biodiversity in those areas. So that's what I think is cool. And again, I want to talk about post-climate change world. So at the moment, this is a figure that Elisa published in 2016. She's speaking next, hang around. And shows restoration projects all over the world in our database. So TNC, please give me your data so we can add you to this, otherwise nobody will know what you do. Just kidding, quite famous. So you can see if you look at the total area restored, that even though it looks like it's widespread, the total area is really small still for coral reefs. Like we're still in the pilot phase for coral reefs, and like it's just orders of magnitude smaller than the kind of restoration that's been done in the mangrove restoration space. So this is an updated, thank you, Elisa, graph of the sizes of the current scale of marine coastal restoration projects. And I just want to point out that little yellow dot on the side that points to this being a log scale. So as you can see, the median size for a coral restoration project at this stage, and this is up till March 2018, is 40 metres squared. So just reiterating that there really needs to be some work on how to upscale this, which leads me to my next point. Pioneers. So scaling up examples, you probably all would have been to SERA's talk this morning, and she's talking again in this session. So 2011 to 2014, you can see in this figure the difference between transplanted and degraded sites. And there was a beautiful video this morning that made me feel like crying on the difference in those two sites and what those different communities looked like. So these are half a hectare, and that's above average for a coral restoration site, and just the sheer number of coral colonies that are planted out. This is a really good example of upscaling coral restoration, but I won't say any more about that because it's going to be talked about in a minute. Just a plug for TNC. Just looking at Port Phillip Bay oysters, these guys, they put in a bunch of limestone rubble so that the oysters aren't suffocated on the sea floor, and for $250,000 had a 600 metre square project. So that's the kind of costs that you're not going to see for coral reef at this point. So these are really different ecosystems, and they have really different economies of scale at this point. So we really need to put our thinking hats on when it comes to restoration. Next scaling up example is a plug for Ben Brown, who's speaking on Friday in the Marine Restoration Symposium. I'll be chairing that one, so look for our names. This is community-based, so you're looking at much bigger scale that we saw in the other ecosystems. So all in Indonesia, anywhere from 12 hectares to 4,000, and this is all about people power. So he's going to talk about that a bit more, but these have been really successful. And the last example that I want to talk about is a group, a startup company that I met in Cairns, and I'm going to go and visit them in December. So they just won or were nominated as like coral innovators of the year or something like that. And they're a commercial coral farm. They just this week started building a land-based coral farm which uses microfragmentation to grow 10 species of local coral in Grand Bahama. And they are financed by insurance companies, by the Port Authority, which recognises the value of tourism, and they have a plan to start showing tourists through their coral farm, and tourists will be able to adopt a coral. They've just applied for an X Prize grant, which would see them look into technologies for outplanting with robots, which is nuts. And they have regimes in place, plans for regimes in place where they will be putting corals under heat stress and acid stress while in the tank environments to try and put them through a process of assisted evolution. And their ultimate goal is to scale this up to 100 countries. So these are the sort of things that I think that are great that people are even thinking about. Whether or not they fail or succeed, at this stage I'm not sure that really is what we should be focusing on. What's really important to me is that they're going for it. So hopefully that's inspiring. Looking forward, I think that we really need to be talking about joint efforts. We're academics, or most of us are, but we need to be working with practitioners and citizens and traditional owners, and we need to make this profitable so that we can close that funding gap, which is where the cost-benefit analyses and spatial analyses really come into play. So with that, I will hopefully introduce Elisa, who will be talking about cost and feasibility of restoration. So thank you. So I'd like to introduce Elisa. I can't say your last name.
Bayraktarov.
Yep. And
Bayraktarov.
Exactly.
And now everyone. 1, 2, 3. Bayraktarov.
Nice. So Elisa is one of my co-supervisors here. She published a huge database on cost and feasibility of 5 different ecosystems in 2016. And she's going to be talking about marine coastal restoration in the last 45 years. And I hope it'll be really enlightening.
Okay. Hi guys, how is it going? I'm trying not to lose my voice. I'm actually recovering a little bit from a cold over the last couple of days, but we'll get there. Okay, the idea of this presentation is just to give you a little bit of an overview of what has happened over the last 45 years in terms of marine coastal restoration. And here again, we do not care just about coral reefs, we actually care about everything: coral, seagrass, mangrove, salt marshes, and oysters. So you'll see examples of all of them. Let me get started. So why do we really love marine coastal ecosystems? Well, because they're highly productive and really valuable. And why? Because they're giving us for free all these beautiful ecosystem services. So they're needed, like corals for coastal protection and fisheries and tourism, and seagrass for wave attenuation and erosion control and fisheries and many other things. Mangroves, again, coastal protection, storm and flood damage, and salt marshes, of course, and oyster reefs for water quality. We already saw a beautiful video by Ian showing how efficient oyster reefs were actually doing water quality improvement in an aquarium tank. That was quite impressive. And all of this different marine coastal ecosystems, of course, are providing habitat for many, many, many species, so they're really valuable. Let me guide you quickly through the techniques of marine coastal restoration. So what has been done over the last 45 years, and for which ecosystem? So for coral reefs, there have been several methods employed where, for example, people would take coral colonies and directly transplant them to the degraded reefs, or like Peter's group, people would use larval enhancement where they will seed the reefs with larvae. There's also the coral gardening approach where people will take small fragments from donor colonies, grow them in underwater nurseries and plant them out when the coral fragments are big enough to survive the natural habitat conditions. And then there are things like substrate addition where people would use artificial reef structures to enhance the recruitment of corals from neighboring reefs, and also substrate stabilization, especially in this case where giant cruise, well, that's actually a Navy minesweeper, destroyed a reef. So they will probably have employed some substrate stabilization there to encourage more coral recruitment. For seagrass, and I'm pretty sure you'll hear lots about that from John later today or tomorrow in the Seagrass Symposium. So what has been done for seagrass restoration is that people have been using quite often hessian bags. That's an example from South Australia where this Amphibolis seedlings have this grappling hook that can actually attach to the hessian bags and grow. And people are also using the transplantation of seagrass shoots and mats, but also in Western Australia especially, quite often the seeding of seagrass seeds has been used as a restoration intervention. For mangroves, well, you get lots of wild seedlings, and after restoring the natural hydrology, those ones will grow quite beautifully. So the only thing you need to have is lots of hands that will collect these wild seedlings and actually plant them, and then they should grow. Often also aquaculture ponds are restored back to mangrove habitat, and in some cases also salt marsh has been used in addition to the restoration interventions to actually trap and retain the wild seedlings when they fall down. And for mangrove restoration, quite impressive is the fact that those projects always have been reporting high numbers of volunteers and community members who would actually take on and be involved in these projects, making them especially cheap. And Salt marsh restoration usually works in two phases. So phase number one is usually where people restore the natural hydrology, and the second phase constitutes of planting of salt marsh plants. For this particular ecosystem, when we were carrying out the global review, we couldn't actually find any examples from developing, countries who develop, how is it called now? Countries with economy in development? No. Something like that. You know what I mean. And last but not least, oyster reefs have been often restored by the deployment of natural, like old shells, or artificial, which is concrete structures, substrate for oysters to settle on them. And often people will get oysters from oyster hatcheries, larvae that will go and hopefully populate the structures. And also interventions have been using no-harvest sanctuaries where oysters were just left to alone without eating them. And once again, world-leading organization in oyster reef restoration is the Nature Conservancy. I think this has been mentioned a couple of times today. So in 2016, we did a global review on marine coastal restoration, and what we did was we looked at all studies that were reporting either on cost or feasibility. And when we started reading through the studies, we realized that the only way that people would report across different ecosystems in terms of feasibility was the survival of restored organisms as an item-based success indicator, but not necessarily as an overall project feasibility indicator, so to say. So what we did this year with the help of Phoebe, we expanded this original database now to 2018 literature, so I'll show you some unpublished results over the next couple of slides that includes this data, and hopefully one day we'll publish them too. Okay, reported costs. It has been always criticized that coral reefs restoration is quite expensive, and I have to mention that when we included the studies of the last 4 years, it even became more expensive for some reason. So strikingly, coral reef restoration has a median cost value of $470,000 to restore 1 hectare of coral reef. Probably it's possible to do it cheaper, I don't know. Number 2 are the oysters with 145,000, and then we have seagrass with 112,000, and salt marsh is about 45,000 US dollar per hectare. And again, the cheapest ecosystem to restore. Invest all your money into the restoration of mangrove because they're just cool. They're very, very, very cheap to restore, or just the least amount of funding has been spent. I don't know. Take it as you want. I'm pretty sure this number doesn't take into account all the hundreds of people and helping hands that have been donating their work in kind support. Yes, the area restored. Again, coral reef restoration, quite experimental. We now know that massive coral restoration projects are possible. SERA is going to talk about the biggest coral reef restoration project, to my knowledge, of I think 1/2 a hectare. But this is a median value of everything that we found in the literature so far. And then, again, mangroves seem to be the absolute winner in terms of what is possible to upscale. And all the other ecosystems like seagrass here and oysters have just restored 1 soccer field. I was told, show examples about soccer fields and people will know. So, okay. Project duration. Believe it or not, the literature is reporting project duration between 1 and 2 years, and this is pretty much, to me, illustrating the length of a PhD study or a master thesis or a very short grant. So for some reasons, at least published restoration projects are not going, in the marine world, are not going for longer than 1 to 2 years. And survival as a success indicator or feasibility indicator. Here, with the updated values of 2018, the salt marshes seem to be doing best, followed by coral reefs with 61%. Seagrass and mangroves are about the same, with just a little bit above 40%. And for some reasons, oysters, the median value of survival from oyster reef restoration has lowered since our study in 2016, now that we've included some more published literature over the last couple of years. So, did success depend on money spent? I was really hoping that I'll be actually able to draw a nice correlation between survival and reported restoration costs, but it's still not happening. So it seems that marine coastal restoration is still not robust enough so that you'll see a clear increase when you actually increase the expenditure. And something quite interesting was that in 2016, I'm sure you're probably all aware of the standards that the Society of Ecological Restoration has implemented in 2016, first as national standards for Australia, and then those standards have been implemented as international standards, for the world, pretty much. And those standards have 6 key concepts as to what practitioners of restoration, of ecological restoration, should follow in order to lead them to success. And what we did was to look into the literature of the database from the 2016 publication, and to actually find out how many of the studies were actually complying with these 6 standards. Let me just remind you, the key concepts of carrying out a successful restoration are the following. You gotta have a reference site that you're comparing your restoration to. You have to have clear, smart targets and goals. And this T here is quite important. It means time-bound. You have to have specific measurable indicators. In a best-case scenario, you should employ adaptive management. And also you should assess the natural recovery potential of your habitat before you do restoration in the first place. And you should be aiming for full ecosystem recovery. And finally, these 2 are, you should elicit all available knowledge, including knowledge of traditional owners. And you should have early and ongoing stakeholder engagement from the very beginning of the restoration project. So we just looked, this is work that we did with Chantal Brisbane, and we looked at how many of these studies were actually complying with these 6, and well, you see, no, well, partially. Here are the specific measurable indicators, well, no. So these 6 standards seem not to be really working very well for marine coastal restoration for some reasons. Again, if you would like to know what actually motivated marine coastal restoration, Chantal is going to present a poster today where we looked at what people were having as objectives to restore this ecosystem, what they measured, and also how they would report on success and outcome of marine coastal restoration interventions. So just come and have a look at this poster. It's pretty cool. Still, I mean, marine coastal restoration is quite expensive, but it's feasible. And we really should draw hope from actually progressing on it by thinking that reefs and coastal wetlands actually provide quite a bit of ecosystem services worth, $8.3 trillion. But projects should be really designed to benefit communities and to involve them from the beginning. But we also need to improve the science and develop methodologies that are really robust and cost-effective. And how to scale up marine coastal restoration? What we think would be a good approach is, as Phoebe mentioned, we have to join efforts, have academics, practitioners, and citizens together working hand in hand. You need to capitalize the restoration projects and get businesses interested, and this is already happening. Ask me later how I know about it. You have to come up with some kind of innovation that makes the restored sites really resilient to climate change, and not that the next coral bleaching event is going to smash your coral nursery. And finally, and most importantly, you need to prioritize where, what, how much, and how to restore. And with this, I'd like to say thank you.
Thank you, Elisa. We have next, got my glasses on. Oh, great. Next speaker is SERA Frias-Torres, and I will get you your... Oh, yeah. So hopefully you all saw her talk this morning, but we're really thankful to have her here to talk to us, and I will pass you over. Oh yeah, I'll do that right now. And then we can just...
Okay, excellent.
Yeah?
Buenas tardes. There's going to be a little bit of overlap with my keynote presentation today, so hopefully you won't fall asleep. I'm going to show you how to upscale coral reef restoration using the coral gardening method. So we're traveling to Seychelles, Indian Ocean, to this set of, I don't know how to make this work. Well, this chain of a sunken continent of Lemuria to the tops of mountains, which are the granitic islands of Seychelles, this is how they look. And Seychelles has quite an abundance of hard substrate, granitic and coralline, for corals to recruit to. And in 1998, there was a massive mass bleaching from a coincidence of El Nino and the Indian Ocean dipole. So 97% of the corals in the granitic islands died from bleaching. And in 2004, there was the Indian Ocean tsunami, which broke down whatever corals were still standing. These resulted in corals going from highly diverse to very degraded state. So I was privileged to lead a group of scientific divers and volunteers in a USAID, United States Agency for International Development, funded project to do large-scale coral reef restoration. This is a dive through the control healthy site. This is a site that has survived the 98 coral bleaching, and you can see massive table corals, which are the size of this table. It was full of life. You can even hear all the noises here. So this was our reference site, and this is what we wanted to compare with when we completed the restoration effort. This is the degraded site, controlled degraded site. It looks like a moonscape, literally. It was completely devoid of life, and the only structures you see are the settlement plates we deployed to measure coral settlement. And so the degraded site was, the restoration site was exactly like this one prior to any restoration action. And this is how the restored site looked like when we finally finished the restoration. And I remember when we were filming this sequence, I was literally crying of joy in my mask, so yes, it worked. So this is about 25,000 corals. All of them were grown in nurseries. I'm going to show you how we did it. Each one of them was cemented into the substrate, and they grew from thumb size to football size within a year. And we had a mix of Poecilopora and Acropora species that I'll show you how they look like. So this is the entire project in numbers. To this date is the largest single project ever done on coral reef restoration. It surpassed the 10,000 corals outplanted. And the techniques I will show you right now is something that could be easily extrapolated to the Great Barrier Reef. So if anybody's interested in hiring me to restore the Great Barrier Reef, here I am. Call me. All right, so this was the mandate from USAID: bigger, better, cheaper, which meant you have to achieve large-scale coral reef restoration. At the time, it was more than 10,000 corals in nursery, more than 10,000 corals transplanted. Better, it meant that we had to demonstrate the restoration action had tangible results. And cheaper, we had to use the resources in a developing country. Okay, so nothing fancy that you can find in the United States. My answer to them was MacGyver everything, using biomimicry. So biomimicry is that you look into nature to find inspiration, to find technical solutions to your problems. So this is the first stage. We are now deploying a nursery. This is hammering iron bars into a sandy bottom. This is down at 18 meters deep. It builds a lot of muscle. That iron bar is one of those black bars you see here. So that gives you an idea of the size of this mega nursery in the ocean. The iron bars are 18 meters deep. The PVC pipes over there are at 8 meters below the surface. And then across the PVC pipes, we deploy 20-meter long ropes, and each rope will be holding 80 to 100 corals. So in total, one of those rope nurseries will be holding 5,000 corals. We had 8 of those nurseries, so we had a total nursery stock of 40,000 corals. This is the biggest rope nursery ever built. We use models and structures developed by the Israelis that were about the size of this table and were only holding 100 corals. We upscaled to 5,000 corals. The yellow squares are jerry cans. Those are the buoys that keep the nursery afloat, 8 meters below the surface. Those were recycled jerry cans filled with air from our scuba tanks, cheap. The PVC pipes on the rope is things that we found in the landfill, so $0, everything very cheap. So first you extract fragments from survivors of the 1998 bleaching, and you go chisel and hammer, very Michelangelo, and we calculated that we can extract only 10% of a colony, and that way the colony recovers and doesn't die. That's the donor colony. We use a mix of species, branching, massive, and encrusting, and we were doing this mix of the fast and slow growers. Fast growers, they will give you structure very quickly, whereas the slow growers will give you more resilience to the coral. So in the site, in the island that I show you in previous slides, we use the corals in the yellow box. And then at a hotel resort, we use the massive and encrusting corals. So I'm going to focus on the ones in the yellow box. So after you take the fragments from the donor colonies, you refragment to the size of your thumb, and you stick them into the rope that is going to go to the rope nursery. You untwist the rope, stick the fragment, twist the rope again. You can do this very fast, and the goal is that the corals eventually will self-attach to the rope, because the living layer of tissue, the sinosarc in the coral, grows over the rope, the point of contact with the rope, which means that you don't need additional connectors, which means that your project is even cheaper. So we also use a net nursery. For this, we were happy or unhappy that there was a fat fishing aggregation device from the tuna fishery that crashed into our island. And so we turned all that mass of net into 3 net nurseries. And we use those for the massive and encrusting corals. We also use high-tech tools to clean the nurseries. Toothbrush, medium strength, and because when you deploy anything in the ocean, everything and their mother wants to attach to that nursery. So we have to fight all that biofouling, otherwise it will kill our corals. And so this is how we cemented the corals into the substrate. We use a pastry chef bag, but instead of creme fraiche, we put a cement mix that we developed, and then very carefully you find 3 points of contact. You squeeze it. You have to make just the right mix to make it squeezable enough, so that's a scientific term, and then you just attach the coral. And then, within a month, in the same way that the corals grew over the contact point with the rope, within a month, the sinosarc grows over the contact point of the cement and makes contact with the substrate. So the coral self-attaches also to the substrate. So that's another way to save money and to use biomimicry. And so some results, we deployed cameras and we're freaking out because we saw hamhead parrotfish recruiting to our nurseries. The nurseries in themselves became floating ecosystems, and we were scared because you might know that hamhead parrotfish is a known corallivore, meaning it eats corals, but they were very well behaved. They didn't eat any of our corals. So thank you, hamhead parrotfish. And so in the net nurseries, we discovered that they recruited their own ensemble of fish, their own fish assemblages, and it turns out that the nurseries with the most amount of fish were the ones we had to clean the least. So then if you build the nurseries just the right way, they will recruit the fish that will clean the nurseries for you. So that's good. Then also, we went where nobody had gone before, so scaling up brought a number of problems. Among them, we discovered that when we passed the 10,000 coral mark, that nobody had passed that before, our corals were becoming dislodged. Our cemented corals were becoming dislodged. And we discovered that it was the fish that began populating the restored sites that were ramming against the corals to get to the mobile invertebrates that had recruited in the nurseries. So we had to use that to our advantage. So we took inspiration from the cleaning stations that happen in coral reefs, you know, when big manta rays come and little fish come to clean them up. So we developed an experimental system, and we discovered that if we deployed the ropes full of corals from the nurseries within 30 centimeters to 2 meters from the seafloor, and we left them there for 24 hours, there will be an entire community of fish that will clean the corals for us. And they will line up like when you are in the buffet here with the coffee break and clean and eat all the creepy things that were in there. So they will leave the corals behind all shiny and clean. And the cameras we deployed demonstrated that we will see the fish we accounted when we were doing visual surveys, but the ones in red are fish that we only saw with the cameras deployed. So that is teaching us there's an entire fish community in the coral reef that we cannot quantify when the divers are in the water. Maybe they are too shy, or maybe they didn't talk to their agent, you know, to have their picture taken. So then we also have a massive increase in coral cover. Healthy side blue, transplanted side red, degraded side green. And from the beginning to the end of the transplantation, we had a 700% increase in live coral cover. We also saw that our transplanted site increased coral sediment and coral recruitment when compared to the healthy and degraded site, which means that we were attracting new coral babies from the species we transplanted, but also from species we didn't transplant. And we also saw that when the coral bleaching of 2014-2016 came along, the corals in the transplanted site compared to the healthy site bleach at a higher percentage rate, but they recover also at a higher percentage rate. So their mortality was lower compared to the healthy site. So we had achieved all the things we wanted to do. We had achieved recovery of ecological function, recruitment of new corals, and survival of a new bleaching event. So we're very happy, and I'll take all your questions now. Thank you. Yeah, that's fine.
We have a little bit of time for some questions, so if anybody has any, I can bring this microphone to you.
No
Oh, over there.
one question. Yes, so the question is if we can talk about the challenges of further bleaching because of increasing temperatures. So in this case, because we selected donors that had survived previous bleaching event in the 1998 bleaching event, our corals, obviously our corals had inherited that resistance or that resilience, and that also shows in the way the restore site responded. However, we know that coral bleaching events are happening at shorter timescales. They're coming faster and faster. They are getting more intense. And obviously, at the same time we work on coral reef restoration, we do have to work on reducing the use of fossil fuels and reducing the impact of climate change. In addition to that, there's also very active research working with hybrids and trying to look at how resistance to bleaching is inherited and how you can build new hybrids from existing species that will respond better to higher temperatures. Yes.
I think there's a good opportunity to do some further integrated research between rehabilitating plants and rehabilitating corals.
Yeah, and that's one of the points that I made in my paper. So in the case of Indo-Pacific coral reefs, it is essential, I think, to do multi-species restoration, not just meaning many different species of corals, but also corals with giant clams with something else. So in the case of giant clams, because they co-evolve with corals in the Indo-Pacific reefs, there is this integrated nature. They really work together. The problem is that we have fished out and literally caused so many local extinctions of giant clams that we're not seeing that signal anymore. But so the next stage will be to integrate aquaculture facilities that are growing giant clams throughout the Indo-Pacific and incorporate them into the restoration of coral reefs. So yeah, and if you find the money, call me and we'll do it. We'll work together on this. Yeah. So yeah, in terms of biodiversity, how long does it take to start seeing the differences? And I can answer the question regarding the fish, because I think that's what you're looking for, right? Because that's what I can answer with this project. Yeah. So, for example, in our case, we discovered by accident that once we reached 10,000 corals transplanted, the fish started to show up. And when I say the fish, I talk about 4 to 5 different trophic levels of fish. So it seems that the threshold number, at least for that system in that part of the world, was 10,000 corals transplanted at a density of 4 to 5 corals per square meter. And once you reach that point, the wave of fish that you see coming in, it's quite massive, and we have another paper showing that. So that means that it's critical how many corals you are outplanting, at one density you are outplanting them, and the area that you are using for the outplanting. That's when you start seeing those biodiversity changes, at least in this system, yeah. Yep. So, thank you.
Okay, I think that's all we have time for. Thank you so much for coming and speaking. So next we have Simon from TNC. From TNC, right? Yeah, replacing Chris. So we're very happy with that, aren't we? Little dig. So your talk didn't have a title and still doesn't.
Oh, just wait and see. I know you're all on the edge of your seat.
So mystery talk.
So,
Thank you, Simon.
Thank you. So yeah, I'm the guy that was unorganised and didn't get a talk title in. But now I can put you out of misery, and I'll be talking more generally about how we perceive what our approach to scaling marine restoration is. So first, let's start off with, I guess, a few numbers. So some of you may have seen this, but a paper that came out in 2015 looked at the ecological restoration economy in the US. And it said that it created 2,200,000 jobs, and this indirectly and directly equated to 25 billion per year to the economy. Now, we've heard a few billions get bounced around, so I just want to take a moment and have a think about how big that number actually is. If you think about countries in the Caribbean, Jamaica last year had a GDP of about 14 billion. Bahamas had a GDP of about 9 billion. So the amount of money that was spent on ecological restoration in the US in, I think, 2014 was around the GDP of 2 Caribbean countries. If you put that in the context of jobs or industries, that's more than the logging industry, more than the coal industry, and also more than the steel and iron industry. For me, that's incredibly exciting. You know, if we could be even getting to a small portion of that in Australia, and particularly, you know, having such a great coastline that we do, that would mean that there's a lot to scale and put into marine restoration. So if we get to that point, how do you think we can generate the ideas and the potential and the momentum to be able to start pushing out these projects further afield? So when I first started at TNC, there was one word that I heard Chris and a few others using quite a lot. Me being an ecologist, I used to roll my eyes a little bit and think it's a bit of a buzzword. But the more that I've spent working in this area, the more that I feel as though it fits. So bear with me here. And that's entrepreneur. So part of my issue was that it took me a while to find a definition that wasn't solely nested in business. So the important thing from this definition is a person who organises and manages any enterprise. And the last two important things are with considerable initiative and risk. And as we all know, in ecological restoration, and particularly marine restoration, there is risk associated with it. We're not 100% certain at every site we're going to have success. If we break this down a little bit more, the true essence of entrepreneurship is based around 4 things. How we go around defining the project, defining what our successes are. That means that we can invest, and by invest I don't necessarily mean money, it's other things as well. And then using that, building. And then finally, repeating. So I'll touch on each of these as I go through the talk and hopefully give you some examples. So first off, we've heard this a little bit in previous talks, but how do we go about making restoration a priority? I think in the marine space, we're limited by the nature of the ocean, and that's the surface of the ocean often prevents people being able to touch, see or feel the ecosystem. You know, they they can't quite get a handle on why it's important for us to be doing these things. So if we use benefits to people to define that conservation and restoration problem, then I think we can do this a little better. So if we think about those ecosystem services or benefits to people that we see associated with marine systems, when we're having conversations with stakeholders, we can connect these to specific beneficiaries. So we can link in our conversations to the ecosystem services or the benefits that best resonate with the audience that you're talking to. This may differ between them, but the other nice thing about ecosystem services is that often it's not just one of these that are found or being provided by a habitat. So these things can be stacked or bundled. One of our projects, a project that I'm working on, is called our Mapping Ocean Wealth project, and this is really about defining those ecosystem services or benefits for the coastal continuum, so salt marsh, seagrass, and mangroves. If you want to find out more about this, come and talk to me later. I can talk at length. The other part of it is how we go around defining restoration success. Our audiences and stakeholders want to know how successful their investment is. Part of the work I've been working on, and we've been working on in TNC, is developing report cards that talk to each of these restoration targets. And presenting it in a way that anybody can pick this up, and it's a snapshot in time. Anybody can pick these up regardless of what industry they're in, and they can understand the success of the projects. Again, if you want more information on this, then I can talk at length on this as well. So once we've got those definitions, we can start to put them together. We can start to use them to understand how much benefit do we get from a restored reef. So this is work that's been done in the US, and we've transferred over here, and we're looking at, really trying to get local ideas of some of these factors. So this is the sort of things that 20 hectares of restored reef can do. So this sort of information can also, this sort of new investment can also drive restoration. Our shellfish reef projects both in South Australia and Victoria have been funded by recreational fishing funds, but also we've used economic modelling to understand the benefits to regional economies. And talking about scale here, the Windara Reef first started off with a 4-hectare patch, and we're currently, I think, about 75% through building the 20-hectare patch. So this was initially seed funding that started at 600,000 and then built to 3.7 million. So almost 1 million of this came from the National Stronger Regions Fund, which invests in infrastructure projects which deliver economic benefit and addresses disadvantage. This really is a milestone for conservation, as it is the first time a blue infrastructure project has been funded out of the construction budget. During the same funding year, this amount of money was also spent on these sort of projects. The way we managed to leverage this money from the federal government was to conduct a business plan. And this really looked at, for an investment of $1 million in reef restoration, what sort of full-time equivalents do we get out of it? And we found that for shellfish restoration, we got about 8.5 full-time equivalents. Now, if you look at this compared to other industries, you can see that for the roads and transport, that's the closest to reef restoration. That's about 5.9 full-time jobs. So this is considerably higher when compared to investment in other industries. So we can see by defining jobs and ecosystem services, we can start to make the case better. And what we hope is that we'll be able to tie into bigger pots of funding to start scaling some of this work. But it's not only defining, we have to build and invest time in making friends, building partnerships with government. Governments who are funding us want to see that we're working together. That's with traditional owners, that's with managers, that's with the governments themselves. So by building and investing time into these networks, then we can really start to harness the power of people. We also need to invest in building capacity. It's not just, we can't just rely on making connections. We've got to be able to transfer knowledge between people. So that's transferring to community groups. We can't just rely on one or two organisations to be scaling marine restoration. You know, we need to be able to transfer this knowledge to community groups, to traditional owners, and they can take potentially smaller projects, but at multiple sites in different geographies. The other point to make is that we need to invest in time. Patience is a virtue. I've heard him mention a few times that the bureaucratic process is a bit slow in Australia, but our colleagues in the US assure us that it's much faster than it is over there. Alongside that is, you know, you get more and more people together, you get government together, things take time. It's okay that they take time because it allows us to think and plan properly. But finally, we need to be able to repeat this. Once we've done those steps in certain geographies, in certain places, we need to take these elsewhere. We need to take them to different locations within those same geographies, but also to different geographies. We can't be afraid to fail just because we're taking things. With an adaptive management process, we can learn and we can apply things in different places. So I guess the take-home message is really a mantra that maybe we should all look at ourselves in the mirror in the morning and say, what are the things we need to do to drive this forward? We need to define, we need to invest, we need to build, and importantly, we need to repeat. So as managers, as ecologists, as academics, and as restoration practitioners, maybe we need to think more, not necessarily as entrepreneurs, but as naturepreneurs. That's bringing us all together, and that's thinking about defining, investing and building in nature. Thank you.
We have a couple of minutes for questions, if anybody has any. Oh, you want me to talk to the question?
That's a very good question. I wasn't involved in that particular part of work, but I'll endeavour to get back to you. But if anybody else might know the answer, then apologies.
Would you still agree, though, that mitigation and prevention of damage is still should be our top priority, and how do we build an industry in that?
Sure. I think it's you know, like with coral restoration, I think that, you know, one approach is never going to satisfy everything. I think that the nice thing about restoration is it's practical. People feel as though they can be getting involved. I don't know whether mitigation and other things are necessarily, they're just as important, but I don't think people can get involved in them to the same extent.
I have to be open. I mean, we've got a lot of people here who thought about this. How can people directly affect the status of these marine ecosystems?
Mm-hmm.
People are, Facebook always memes going around about what we do with plastic bags and so on. We need to be, I think that's quite right. We really need to be looking at ways to engage people actively. It's not the topic of this talk, but
Like I said, I don't think it's the only solution. I think, you know, there's other people who are doing this.
Yeah.
We've decided this is our approach.
oh yeah. No,
And,
it's not criticism of TFC.
Yeah.
But
I do think it's equally as important.
who do we go to find out who's doing that? How do we find out who's doing that sort of activity?
The kelp people are doing that in Sydney. I know we left them out of our analyses, but they did. Is it who's Kelpie? Are you a Kelpie? Yeah. You guys did a lot of public engagement, right? Yeah.
And restoration provides a mechanism through which people can learn and share understanding and intention together. So it's a way
That's right.
because it's so hands-on.
Yeah.
And makes it personal.
Was it called crayweed? Yeah. And the little craybees? Okay. I think that's sorry for. Thank you. Thank you very much. Okay, so next we have John from WA beginning his tour. This is the first of his three-stop tour at the SERA Restoration Conference. This is yours, right? Okay. He's taking over from Gary 2.0. Thank you.
Thanks, Phoebe. So, yes, Gary Kendrick was supposed to be here to give this presentation. Unfortunately, he can't be here. This is what Gary looks like. I'm not Gary. We're very different people. This is what I look like. I was going to actually dress up like him. I can't grow a beard at all. And I didn't really want to shave my hair. It's pretty hard to get rid of this mop. So the presentation that he's put together for me and basically sent to me this morning was on the social and ecological challenges and new directions in seagrass restoration, and I've added a few other things in there just to make it a bit easier for me to convey this message to you all. So for those of you who don't know about seagrasses are marine or underwater flowering plants that basically the majority of species complete their whole life cycle completely submerged underwater. Okay, so they go from sending out these runners to cover large areas, to producing flowers, pollinate, fertilisation and seed production all underwater for the majority of species. There's 72 species worldwide, and seagrasses occur basically on the coastal margins of every single continent, with the exception of Antarctica because it's a bit too cold and a bit rough for them. Unfortunately, we are losing our seagrasses, and as Simon sort of pointed out before, and I think some other presentations as well, is that a lot of people aren't really aware of this, because below that blue line, people are not really seeing these habitats. And in fact, a lot of people are actually scared of seagrasses. It's pretty hard to believe, but a lot of people don't want to walk in seagrasses for the fear of stepping on something sharp or dangerous, or being bitten by a crab or something along those lines. And I've basically had all of that done to me, so I understand their fears. It is definitely a fear that is there, but they are quite important habitats along our coastlines. And so globally, we've lost about 25% of our seagrass habitats, which equates to about 51 to 52,000 square kilometres of seagrass habitat lost globally over the last 100 years or so since observations begun. And we're continuing to lose this habitat since the late 90s at a rate of about 7% of its distribution globally, which equates to about one football field-sized area, so a soccer field, every 30 minutes. So we're losing seagrasses at that rate. And soccer fields are, again, a great comparison. We are trying to do something about this. We are doing a lot of conservation efforts to try to prevent seagrass losses, and we have reduced some of those losses from the 60s, 70s and 80s, but we are still losing seagrasses at a relatively high rate. And so intervening in a way where we can actually try to return some of these habitats back to areas where they no longer have these pressures put upon them is a process that we're going through globally. Now, there's been close to 1,800 trials trying to restore seagrasses globally, roughly about 215 projects. And in this particular diagram, so if we look here at this little figure on the side here, these are the number of shoots on the bottom here that have been included in a restoration. So from less than 100 shoots included in a restoration and greater than 100,000 shoots included in a restoration, and the areas may vary based on the density of the plantings. What we can see is for the majority of programs, we're sort of looking at less than 10,000, less than 100,000 shoots globally planted in the majority of restoration efforts, with a few large-scale efforts, particularly in the US, where they've been able to put out huge numbers of shoots. This was in the form of seeds, and I'll talk a little bit later about that to you all, but the majority of restoration efforts have focused on the use of adult transplants. So they'll go along, take a cutting of that transplant from a donor meadow, and then transplant that to a degraded site. So quite a labour-intensive and pretty cost-ineffective process. As Elisa showed earlier on, you're looking at about six figures, $100,000 plus to restore or replant, I should say, a 1 hectare area of seagrasses, and that can vary from 33,000 and up to 3.3 million, depending on if you want to include some really fancy technology. So the way in which the model we've basically used for seagrass restoration has tended to focus on either bringing back structure or function. So in this instance, we're trying to bring back the 3D structure of the plants, so putting out shoots, or we're trying to bring back some function, trying to improve, say, nutrient cycling in the system or productivity in that system. The problem with a lot of this is that a lot of it is very small scale, as I mentioned before, but it's also been very technique focused. And so we're going out there and focusing on using transplanting techniques. So do we anchor them? Do we add wire pegs? Do we use larger transplanting units? There's a whole suite of things that have been used, and it's really been technique focused, and really the attention's really been brought off of what we're actually trying to achieve, the broader outcomes of our restoration. So the perception of the restoration, so what that is, has really been lost in this message, because as scientists and some practitioners, we've really been focusing on those sort of sciencey questions and techniques. So Abelson and a suite of others, including Gary Kendrick, put together a review sort of outlining this, and they found that there needs to be this more of a realignment towards ecosystem services. The reason being is, for seagrasses in particular, not only are they below that blue line, they're also not very sexy. Right? They're just basically a monospecific meadow that's out there. People can't really get behind that. They've got no real support in that sense from the general population. There's been a lot of efforts to try to boost this over the last couple of decades with some success, but in general, they're not very pretty. They're not like corals. They're not like mangroves that you can see when the tide goes out, and the same with many oyster reefs. Okay, so, and even kelp forests, they're fantastic to dive upon because there's lots of things in there that you can eat. And there's great biodiversity that's there, whereas in seagrass meadows, a lot of the animals are very cryptic. You have to really get your eye in to see what's there in a lot of cases. So they're seen as the uglier cousin of the corals and the kelps, unfortunately, poor things. So this realignment towards ecosystem services is really what's something that we think is really important to drive a boost in trying to scale up our restoration. And this example has been really demonstrated in the Virginia coastal bays by a colleague of ours, Robert Orth and his team at the Virginia Institute of Marine Science, plus a team from the Nature Conservancy, plus a whole range of community groups and state officials that have been involved in this restoration program to bring back eelgrass, salt marsh and oyster reefs. But they've done so in a way where it's focused on the ecosystem services that these habitats are providing. So for the seagrasses, it's really a focus on the bay scallop, but also other important fisheries, commercial and recreational fisheries, including blue crabs and fishery, mental blank, sorry, and bay scallops, of course. And so there's been this really big push for that, and obviously stripping out nutrients from the water column. Seagrasses are very good at filtering the systems, and also the amount of seagrasses that have been lost in this system, they're very good at stabilising those sediments. So when their seagrasses aren't present, you see this major change in the quality of the water, so loss of transparency, and therefore you get a decrease in seagrasses as well. So just to go through a bit of an example of the work that they've been doing there. So in the late 90s and into the early 2000s, they've been really developing these techniques to scale up their restoration. So how do they go about collecting the quantities of seeds they need to cover the area that they need? Okay, so to date, over the last 15 years, they've been able to collect and distribute about 71 million seeds within one of the coastal bays in Chesapeake. And this particular seeding effort, the blue line here, represents the amount of seeds that they actually put out there. So this year, so 2018, which isn't up here, sorry, they've had their biggest harvest yet. They were able to collect about 11.8 million seeds in a single season, which occurs between May and June each year. They go through and collect these plants, distribute them out, and then this red line here is actually the restored plots. So this is the area of seagrass that has basically been recovered since they've been reseeding here. So they found that in this particular location it was the availability of propagules in these areas that was the major limitation. And so they were able to reseed just under 500 acres and get just over 6,000 acres of Zostera marina eelgrass present, which is equivalent of about 2,000 hectares of seagrass in that period. So repeat seeding was really the key here. And just to give you an example in the images, so this is one of the bays here. They replanted or reseeded anywhere from 100 square metre plots up to 1 acre plots. And then over the time sequence of about 10 years, you see this massive infilling occurring here. Basically what happened is they started reproducing themselves, releasing huge quantities of seeds in this area, and it's basically self-recovered. And this represents this particular area up here. And they've continued this program on down the coastline, and the red here is the 2015 beds, which are showing recovery after reseeding a few years earlier. So the technique's working, and the general public are really getting behind this. So they're actually coming out there in force to help them with their program, getting involved in the collection. They use an automated process, which sits in the front of the boat in the water. It's got a little cutter head on the front, and it collects the spades, which are the reproductive parts of the seagrass. Divers also go out and collect the spades by hand. They get put into this sort of processing tank and they end up with these pure seeds at the end of it. And then people go out there and reseed. This is them broadcast seeding on the bow of the boat. And it's a very efficient, low-cost technique. They can reseed a hectare for about $15,000. So with an annual budget of about $150,000 a year, they're actually able to reseed about 10 hectares a year, and it's a very successful program. Now, what they did during this program was they really pushed getting the public involved. And the reason and how they did this is they were really talking to the public about what are the benefits you're going to get out of oyster reef, salt marsh, seagrass restoration. So return of fisheries, both commercial and recreational, return of the quality of the waterways that you're utilising, and basically the general aesthetics of the area are going to be there. And so they really pushed this over the last 20 years, and as a result, it's had a spill-on effect towards getting long-term funding. So the long-term funding is really what's been boosting this program, where they're able to not only over time but also the scale do the restoration at appropriate timescales and to spatial scales as well. Consequently, they've been able to get this large-scale restoration program happening. And the positive feedback from this is that in these areas that have been restored, the seagrass meadows that I showed you before, they're now going out there and reseeding bay scallops. They're going out there and basically seeing the blue crabs coming back. And they're also restocking fish species which were locally extinct from the area. So there's this really big push in this particular system. And it's really based on this change in perception that they've really pushed towards the general public. And these are just some of the little bay scallops that they've reseeded into the area, and they attach to the seagrasses and can move around. So in Australia, if we look at this particular example, in Australia we really see three key challenges to scaling up seagrass restoration. We've really had, we've done a reasonable push earlier on trying to link seagrass restoration to broader social values, but that science was really developing up at that time. And also just our general understanding of seagrasses back in the 90s and early 2000s, we really started to build up. There's been some issues with methodological challenges as well, so a lack of clear and measurable goals and outcomes. So why are we trying to restore this, not just for the structure, but what are we expecting to get back there? Poor understanding of the site selection and appropriate methods. So we're still working this technique space and we're still trying to build this up. Post all of this is the monitoring side of things. So we're really limited by the length of funding. So a lot of these programs are only 1, 2, 3 years long, and then they get cut and we never go back there and see what actually happens. And as a result, there's been this, in Australia, there's been this perception of seagrass restoration's a failure. And so there's been this stagnation over the past decade to decade and a half, probably about the last decade. because of the costs involved and really this sea of failures in amongst a few good successes that have gone on. And I'm sure we'll talk about this in the Seagrass Symposium, the successes and failures, which is tomorrow. So we thought coming together as a group, and I won't go into too much detail about this, with a national group, which is called the Seagrass Restoration Network, and basically we saw this as an opportunity for us all to get together and start thinking about how we can align ourselves to improve our abilities to improve the perceptions of seagrass and seagrass restoration. Currently, we're sort of in this space. We're really still working this gap analysis with single projects. We're starting to work into this space. We're starting to collaborate a bit more widely across national and statewide networks. But it's still very early days, and clearly this is a bit of a long shot for us at the moment. This change in perception is really something that we're really pushing for, and I'm rushing heaps and I'm out of time. But it's a grey area that we're currently working towards this, but it's these larger networks that we're trying to get together to get everybody on the same page to really improve the perception of seagrasses and move away from this it's a failure and we can't do it to something that is successful and it will have positive benefits. I'm going to skip over this part because it's literally just saying the same thing, and I'll go to the conclusions. So it's quite clear that there is a strong link between human society and coastal ecosystems, not only for the impact that we're having on them, but also our reliability on these for a lot of things like the free services they provide, fisheries, the aesthetics of the ocean as well for recreational users, but also things like coastal stabilisation and alike, and blue carbon sequestration, particularly for seagrasses. Incorporating this social and ecological element into restoration could be a very important way for us to move forwards with seagrass restoration, because it means that we can focus our goals into something in the distance and not just trying to get a couple of plants in the ground, but something to actually aim for. What is the target? How do we actually get to a level where we're going to get, say, the bay scallops to survive? What density of plants do we actually need? And finally, obviously, restoration is a multidisciplinary approach. And as everybody has reiterated, there has to be a lot of collaboration between a multitude of users. And so this really co-designed approach to restoration. So what do people actually, the inputs of the general public in particular, what do they actually want back in this system versus what the scientists think need to be coming back in this system? Thank you very much.
No questions. He went over time, so he doesn't allow any. But if you want to ask John any questions, he's got 2 talks tomorrow in the Seagrass Restoration session. So up next we have Professor Kath Lovelock, who's based here at UQ, and she does some really exciting work on blue carbon. So hopefully I will get
I'm the last speaker of the day.
But where is your talk? It should be there. Oh my God. Sorry, what's going on? Maybe it's just hiding. It was there.
I saw it earlier.
Okay, right, it's probably just. Oh my gosh, where is that? Probably this one. Uh-oh, who's in trouble? It's okay, we've got it, we'll be fine. Just kidding. Classic gag. This one gonna wait for you?
Yeah. Hello, everybody. It's my pleasure today to talk to you about blue carbon and restoration. So I thought I'd start with a definition. Blue carbon is pretty much all of the carbon that's sequestered in marine environments. But at the moment, we're really focused on mangroves and seagrasses and salt marshes, and there's a number of reasons for that. The first is that they have we know that they have really high carbon stocks associated with them. So there's carbon in their biomass and also in their soils. And that's because they're basically angiosperms, regular, well, not regular, but they're terrestrial plants that have invaded the marine environment. And so they bring with them lignin and all sorts of other compounds that actually decompose very slowly in the marine environment because we don't have white rot fungi. So it's that sort of missing part that allows these ecosystems to basically accumulate a whole lot of organic matter in their soils. And in addition to that, they trap sediments. And so that sort of contributes to this anoxic environment of the soils, which basically suppresses decomposition. So we're getting this sort of accumulation of carbon from their high productivity and very low decomposition rates. Right? So there's a couple of other reasons why we like to focus on these particular ecosystems, and that is, of course, we've talked about this. This is like preaching to the choir. They provide a whole lot of ecosystem services, and I really am going to focus here on mangroves because of the time constraints and because I really like mangroves. But this was sort of this suite of ecosystem services was really very well articulated in this report that came out in 2015. So if I have to think about them, like the big ones, fish, and we've already heard today, so many species are dependent, at least some of their life history phases, on mangrove ecosystems. Climate regulation, this is the carbon sequestration point we're talking about. Coastal protection has been, really important in some regions of the world. And then also the improvement of water quality, which is a really big one for the Great Barrier Reef. So the third reason why we really focus on these ecosystems is basically loss and degradation. So these are my three top picks for papers that are good to describe this. The first one is Valiala in 2001, who, drew our attention to the massive loss of mangroves globally, largely to shrimp aquaculture. So approximately, probably 30 to 50% of the forests of the world, mangroves of the world, have been removed for shrimp aquaculture. The second one we just saw cited, which is Michelle Waycott et al., which was about the loss of seagrasses globally. And then finally, which you might not be so familiar with, is that loss of salt marsh habitats that's occurred. And really, I think this started centuries ago. I think the Romans gave it a really good smash in Europe. But, it continues today, in that just last year, the herbarium here in Queensland released a report that showed that 50% of the salt marshes in this region have disappeared since the 50s. Right, so quite recent demise of that habitat. Okay, so there's three really good reasons why we focus on these ecosystems. So when we talk about blue carbon, we are talking about the high levels of carbon that are stored in the biomass and the sediments of these three ecosystems. And we want to conserve them to basically stop CO2 emissions to the atmosphere. Right, it's probably, well, it's estimated that somewhere between 9 and 20% of the CO2 emissions attributed to land use change are actually from coastal wetlands. Right, so we want to stop that. We definitely want to stop that. And then with restoration, we want to basically kick-start carbon sequestration and thereby contribute to trying to mitigate climate change. Right, so that's the driving argument, and really what we're doing is we're using this carbon service that's provided to basically get at all those other ecosystem services that we really care about, right? So it's a mixed bag. Blue carbon isn't just about the carbon, right? It's really about every other ecosystem service, and it's really describing sort of a suite of conservation strategies going forward for these three ecosystems. Right, and this is sort of described pretty well in this report that came out in 2009, which was really where the term blue carbon kind of entered the literature, because lots of us had been working on carbon in these coastal ecosystems before that, but sort of been summarised in a way that was useful for conservation and restoration, really started in about 2009. So this is the way we think about it, really. In intact systems, basically seagrasses, mangroves and tidal marshes are net greenhouse gas sinks. They fix CO2, it's stuck in the soils and the biomass. As we do things like make shrimp ponds and, like turn them into housing developments or football fields, basically we're causing CO2 emissions. We're burning the biomass often. We are changing the hydrology such that they become oxygenated, the soils, and therefore the carbon that's within them starts to get oxidised and we give off CO2 emissions. When they're in their degraded state, they continue often to be sources of greenhouse gas emissions. Right? So CO2 from the degradation of organic matter in the soils, methane. Methane is a big one because they are often converted to habitats that are a lot fresher, right? And freshwater systems emit methane. Right? And then also some of the alternative land uses emit nitrous oxide as well, which is a very powerful greenhouse gas. And that would be some of the converted, for example, cane lands that you add nitrogen to and results in nitrous oxide emissions. So when we do restoration, we're basically turning it around to being a carbon sink again. So, one of the things about blue carbon is it's been all about building incentives for restoration and conservation. So there's a whole range of incentives that I've got on this slide, and there's more than that, right? So some of them have been, some of the incentives nationally are about making your nationally determined contribution, basically meeting your greenhouse gas reduction targets, all right? So to do that, and there in 2013, this document in brown, it's not a great colour, was released, and this is what we fondly call the Wetlands Supplement, because the IPCC has fantastic guidance on how to account for greenhouse gas emissions, removals and emissions from all sorts of sectors, but they'd kind of left out the wetlands. Well, they hadn't left them out. There was a little teeny piece. And it's because, the IPCC is sort of like a consultative community practice, and the only people in the room to begin with were most familiar with bogs and fens. So that's all we had to begin with in the 2006 guidelines. So to address this, they made this 2013 supplement which covers coastal wetlands. And what it does is it gives guidance to countries about how to account for their emissions when mangroves get turned into shrimp ponds, for example, and removals when you restore them, right? So there is some guidance in this 2013 document. So in addition to that, and these other things here actually draw a lot on it, there's a methodology in the American Carbon Registry, which is a carbon market for restoring wetlands of the Mississippi. And within the Verified Carbon Standard, which is another market, there is a methodology for restoration of tidal wetlands and seagrasses, right? And they also have a methodology now for conservation, which is very interesting. And then within this country, in Australia, we have the Emission Reduction Fund. It's our national market, right? And currently we do not have a blue carbon methodology, right? But the Emission Reduction Fund scoped this in 2017. So we could be lucky in that we might get a methodology sometime in, I'm hoping, the near future. So the problem in Australia is at the moment, even though there's all this great work out there, and Australia is a signatory to the Paris Agreement, we actually don't have a methodology we can use yet to do projects, because we can't use this VCS methodology because it's not recognised by our government currently, right? The ERF won't play there yet. So anyway, we're busy in the process trying to alter that. Now, some of the other things that you can use that are incentives are things like organic shrimp. So there's some work there making sort of carbon neutral shrimp. And then also probably, I've forgotten my other possible method. never mind, it'll come to me. Okay, so all of this has been met with a whole lot of global enthusiasm, particularly from Indonesia. This was actually 2014, the President of Indonesia talking about blue carbon at the UN, which was fantastic, right? So there's a lot of enthusiasm, and it's because it's such a positive kind of idea. We can restore, we can mitigate climate change, and in the process we can be better adapted to climate change. It's a powerful package that has been really enthusiastically taken on. Australia's been very enthusiastic, and they formed this International Partnership for Blue Carbon, which tries to support governments to kind of include blue carbon ecosystems within their greenhouse gases and within their NDCs, their nationally determined contributions for reducing greenhouse gas emissions. Okay, so there's also been growing global interest in mangrove restoration, and this is something called the Global Mangrove Alliance. It's an alliance of a range of NGOs, and they have this, super target of restoring 20% of mangroves by 2030, which is a little bit, well, it's very ambitious, let's say that, right? So all of these things are working together, and a part of the idea for this restoration, is possibly to use those blue carbon incentives to drive that going forward, right? So you can follow that one. Okay, but restoration and blue carbon, it raises a whole range of questions, right? So there's technical issues about restoration. How do we restore? Where do we restore? And I've got this picture on the side here just to remind me to tell you that, of course, for mangrove ecosystems, getting the hydrology right is absolutely key, right? It's, that's the one of the fundamental lessons of mangrove restoration. But I'm not going to talk about that because there's people who are much better placed than me. But I'm not going to talk about, in a moment, what are the carbon benefits of restoration and trying to put some numbers on those. And I also want to point to the seagrass session tomorrow, which is going to cover a lot of this for seagrasses. So the next thing that it raises, there's a whole range of questions around socio-economic issues and context, basically community and institutional readiness for these kinds of projects, particularly if they're blue carbon projects. So, for example, in Australia, we do have a problem because we don't have a methodology, right? So I'm pointing out Ben's talk tomorrow because he's going to talk about the readiness for restoration. And then also Sang Fan has got a poster on our project in Myanmar that's out there in the lobby that talks to some of that social economic issues around blue carbon projects or restoration projects more generally. And then finally, there's a whole range of financial questions. Well, I put finance, it's sort of finance and economics. So could blue carbon pay for restoration if we wanted to do it? And then this is a question that's asked a lot by the carbon farming industry, which is blue carbon a cost-effective process, right? Why should we do blue carbon when we could do brigalow or something, terrestrial? Why would we do blue carbon, right? So that's the question. And I don't think I've got time to go into that, but partially the answer to that is because of all the other ecosystem services involved, I would say definitely it's worth it. But we still need quite a lot of work in that space. I also think I wanted to say that blue carbon projects, not all carbon credits are worth the same thing. And, for example, companies are much happier to pay for savanna burning projects a very high price for carbon because of the benefits to Indigenous communities than they are to pay for a carbon credit if it's changing the light bulbs in the Brisbane City Council, right? So we can sort of think about these as premium projects, if you like. So first of all, restoring carbon stocks, does it actually happen? For the above ground material, for the above ground tissues for mangroves, I think the evidence is growing that basically you can restore forests. And here's a plot of some data from a range of sites. From some of these are plantations, Vietnam, from Philippines, from Florida, one example in Moreton Bay, and from Bali in Indonesia. And it's pretty clear, right, especially if you look at Florida, that sort of aqua colour, that that sites differ in their productivities and in the final biomass that you achieve when you restore, largely because of climate and geomorphology and soils and other factors. But what is clear here is that if you have a successful project, you're basically getting stands that approach the reference level in about 20 years. Right? There's some exceptions, but essentially we can regain the forest biomass. And I think at a conservative level we might be thinking about 2.5 megagrams of carbon per hectare per year. Megagrams are just tonnes, so if you're a carbon person you like that. That's a very conservative number, but and it's about what you might achieve with a terrestrial forest. Okay, so the big stock in blue carbon systems is in their soils. But looking at the recovery of soil carbon stocks is actually quite complicated. It's not as simple as looking at the above ground biomass, and that's because soil carbon sequestration is a balance of the contributions from roots and wood and the sediments that are coming in, and also from the outputs. So there are outputs. These are open kind of tidal systems, depending on rates of decomposition and also export from the soil, and that would include erosion. So one other thing that I really wanted to stress here, though, is that restoration can basically halt a CO2 efflux that might be happening as the soil carbon decomposes. So basically you've got an avoided emission if you restore as well, and that's a very valuable part, right? So the IPCC 2013, that's the Wetlands Supplement, nice, gives us a carbon sequestration value for soils of 1.62 tonnes of carbon per hectare per year, based on sort of data from natural forests, not restored forests. I've got an example here from a site in Indonesia of my graduate student, Frida Siddiq, and she's been watching the soil accumulate over time in a reference site and a restored site. And you can see basically there isn't much difference between the two. So in that system I actually give the soil gain due to the increase in volume over time of 2 tonnes of carbon per hectare per year. And then there's also some other examples with restoration of 1 to 2 megagrams of carbon per hectare a year. So there are growing examples that suggest that restoring carbon stocks occurs with restoration. Right? So we probably give these conservative sequestration of about 1 and avoided emission of about 1. I'm going to ask you afterwards to add these up, That's the whole trick. That's why I'm making a point of it, right? So this is one that we're thinking more and more about, and this is basically avoiding methane emissions from the current habitat use. So methane has a much greater warming potential than CO2, and methane emissions are very high under freshwater conditions, and they are reduced with reintroduction of salt water. And I point you to this lovely paper by Kevin Kroger in 2017 in Scientific Reports that basically describes these processes. And this could be a big win for restoration if we can avoid this methane emission. So with tidal reintroduction, the IPCC Tier 1 value gives us 5 tonnes of CO2, up to 16, and so, I'm going to give it an equivalent of about 1.5 megagrams of carbon per hectare per year. So the example here in Australia of somewhere where we might make these wins are the ponded pastures. So these are systems where a bund has been put in place to basically trap the fresh water and keep the salt water out. So they are flooded for part of the year and emitting methane for part of the year. They're bad for fish. They're bad for water filtration. They're sort of like not so good for anything except grazing cattle. And if restored, we actually could make quite a lot of greenhouse gas gains by restoring them. So in Queensland, there's probably about 30 to 40,000 hectares of these kinds of constructed wetlands in all kinds of land uses in North Queensland. So I'm getting to this point where we're looking at greenhouse gas abatement through restoration, and this is a table that's in a report that we wrote that was commissioned by the Emission Reduction Fund, where we explored, the range of scenarios and what basically would give us good greenhouse gas abatement. So the first one here is scenario 1, tidal introduction to drained treeless communities and basically conversion to a mangrove, and you could expect about 15 tonnes of carbon. And the other green one I've got outlined here is the introduction of saline water to ponded freshwater and converted to a mangrove. You're going to get about 13 megagrams of carbon. So that is actually really quite a lot compared to a terrestrial forestry restoration project, right? But the kicker is that compared to the vast land mass of the terrestrial environment, the coastal wetlands, our restoration opportunity is much more limited. Yes? So that is the truth of it. And we actually don't know currently what the true extent of our opportunity is yet to do this. All right, so this is the challenges looking forward. We've done, quite a lot of work. The whole, I think it's poised to do projects. We've done a lot of science. There's still some to do. But basically, what we really need to do now is to do case studies. So will, for example, reintroduction of tidal flows work the way we think it should? So, and at the moment there's a lot of activity in Queensland, in Victoria, in New South Wales, sort of examining those case studies, and there are some that are in progress, right? They're not earning carbon credits, but we're certainly doing, there are groups that are doing the science to sort of support some of these activities. We should think about planning projects, where to plan projects, where blue carbon values are high, where the alternative incomes from the land are low. So, for example, we have a lot of marginal cane land in the wet tropics that's sitting very close to sea level. All right, that could be an opportunity. We want high benefits for water quality, biodiversity and adaptation to climate change. So really we've got to kind of like find those locations which might really make these projects attractive. And then finally we really need to develop those methodologies, or help the Emission Reduction Fund in Australia develop sort of methodologies that are robust and really cost effective, so that we can move these kinds of projects forward here in Australia. Okay, that's it. Thanks.
Thank you, Kath. That wraps up our session. We don't have enough time for questions, unfortunately. But thank you all for attending this scaling up of marine coastal restoration session. And just a reminder that tomorrow we have a couple more marine restoration sessions. We've got the Seagrass session, and then we've also got the general marine restoration session. So hopefully we'll see you all there. And once again, thank you to all our